All right, in this video, we're just going to look and see how to balance a pre-written nuclear reaction. So a nuclear reaction just explains how one atom changes into some other atoms. And the big thing about them is this arrow basically represents an equal sign. Everything on the left side of the arrow was there before. Everything on the right side of the arrow was there after. But the big thing is that you can't just suddenly gain or lose mass or change the total number of protons. So you have a top line and a bottom line, and the numbers have to add up on each side. So let me show you what this means. So if this arrow is an equal sign, on the top, on the left side, on the top, the total is 234. So that means on the right side, these numbers, there's an atom or something that goes in this spot. These numbers must also add up to 234. So we say, okay, 4 plus what is 234? The answer is 230. So I write a 230 up top here because 230 plus 4 is 234. And I say, what goes on the bottom? Well, there's a 92 here on the left, on the bottom. There's a 2 here, so 2 plus what is 92? The answer is 90. So bottom line, a balanced nuclear equation, the top numbers will all add up on each side of the arrow, and the bottom numbers will all add up. The next question is just what symbol do you put here? So the symbol is all determined by the bottom number, the atomic number. So the bottom number is 90. So I consult my periodic table. I'm sorry I don't have that in front of me on the screen here. But you find element 90 on the periodic table, and when you go and find that, you're going to see that it's thorium, which has a symbol TH. So we just put a TH here, and this is now balanced. The nuclear equation is balanced because 230 plus 4 equals 234, and 90 plus 2 equals 92. That's what you always want to check when you're done to see if it's balanced. So let's go to this next one. The top number is 87 on the left. Remember, this arrow is the equal sign. There's a 0 here. So 0 plus what is 87? I put an 87 on top. Then the bottom, this is a little tricky. There's a 37 on the bottom. There's a negative 1 here. So negative 1 plus some number is 37. And the answer is it's 38. Because 38 plus negative 1 gives you 37. So that balances out. And again, what element is 38? We consult the periodic table. We find it's strontium, so the symbol is SR. So again, the symbol always matches the bottom number. That's the atomic number. All right, let's look at this last one. It's a little different. Again, the arrow is the equal sign. So now I'm trying to predict what is going to be formed when these two things collide. No different. The numbers just have to add up. On the left side on top, I have 1 and 98. So I put 99 here. On the bottom, I have 0 and 42. So I put a 42 on the bottom. So 42 is MO. So notice it's the same atom, it's just got a little bit heavier. So when an atom absorbs a neutron, it gets a little bit heavier. There may be another reaction after this, but for now, that is it. So it's really just a matter of making sure the numbers are the same on each side. So let's look at some more examples. So here, the equations get a little more complex. It's not just one thing, two things becoming one or one missing thing. And there is one missing thing, but now we got to just pay attention a little more. So let's look at this first reaction. On the top, on the right, we have 4 and 3, which is 7. So I need 7 on the left side as well. So we just basically say, okay, what number plus 1 is 7? It's 6. 6 plus 1 is 7. 4 plus 3 is 7. On the bottom, 2 plus 1 is 3. So what has to go over here below the 6? Going to have to be a 3, because 0 plus 3 is also 3. Again, what symbol? I look on the periodic table, I find 3, and it's Li. And that's just all we do. Here, this next example, start with the top. 4 plus 27 is 31. And you don't have to write this out. I'm just giving you the example. So what number plus 30 is 31? It's a 1. On the bottom, you have 2 plus 13 is 15. So 14 plus 1 is also 15. And then what element gets a 1? It's hydrogen. Down here, one thing you're going to notice is this number out front, this 4. This is a coefficient. It just basically means there are 4 of these objects here. So what you can imagine is it's either 0, negative 1 4 times, or you can just multiply that 4 by the top and bottom numbers. That's 2 different ways to look at it. So again, if we think of this as the equal sign, I have 235 on the top here. So all of these have to add up to 235, whatever this missing thing is plus these. So I have 90 plus 1 plus 0, but 4 times 0 is still 0. So currently I have 91 over here. I need something else to get to 235. So I subtract 235 from 9. And when I do that, I should get, I believe, 144 is the top number. And so that's the top number. And now the bottom number. So I have 92 on the left So I need to get 92 here. So 38 plus -1 4 times. So that's effectively 34 here. So I got to get to 92. So I subtract 92 minus 34. And so I get, I believe, 58. So 58 plus -4 is 54. Plus 38 is 92. And again, what element's 58? I consult the periodic table. It's cerium Ce. So that is all it takes to balance nuclear equations. Just a matter of making the number on the top line equal on both sides of the arrow and the bottom equal on both sides of the arrow. The one tricky thing is, I said the bottom number always matches the symbol, but sometimes you have atoms, particle not as seen as often. So sometimes you get a -1 on the bottom, and that just means it's a beta particle if the top number is a 0. A beta particle is an electron. If you have a 4/2, that's an alpha particle. It's a very special radioactive particle. Now, you could have just as easily put helium, because 2 on the bottom is a helium atom. Alpha is always 4/2. So if you have 5/2, you can write helium, because that's what it is, but you can never write 5/2 alpha. Alpha is reserved strictly for 4/2. Gamma rays are 0/0. It's just a high form of energy. Neutrons are a special one. Notice they have no protons. That's why the bottom number is 0, the top number is 1. Notice the proton, 1/1. You could just as easily put hydrogen. They're both acceptable, but realize that's an example. And then a positron is a very strange particle. It is effectively a positively charged electron. So it has no mass. The top number is 0. The bottom number is 1. But again, everything else just gets its symbol from the bottom number. So most of the time, it's just going to be look at the periodic table to figure out the symbol, but you should be familiar with these particles, and so you definitely want to make sure you know the beta particle or the electron, the gamma ray, the neutron, and the positron. The proton and the alpha particle, again, you can kind of get by with the classical element symbol, and that should work okay. So anyway, try this for practice, and yeah, that's it. It's just a simple kind of math equation. So until next time, I am Derek Genova. Have a delightful day.